right, in this lesson, we're going to do a little bit of a recap of what we already know about solutions and concentration. But we're also going to look into um, quantitative concentration, so the math behind a concentration of a solution. So I want you to recall what a solution is. So an example of a solution is like if you dissolve some salt in water. Um, it's a solution because there's two or more substances mixed together, but we can only see one phase, or so it all looks the same. Now, a solution is an example of a homogeneous or homogeneous mixture. And when a homogeneous mixture is in liquid form, it's a solution. So I want you to think about what would happen if we dissolve some salt into water. If I had a cup and I put it on the counter and I added some salt and some water and I stirred it all up, it's going to look the same, right? But if I could zoom in and look at the particles in this cup of water, I'm going to see something. I could see something like what I see right here on the right side of my screen. There's water molecules, and within the water molecules, there are little salt particles. Now, we've talked a little bit, or we may have talked a little bit about how the salt dissolves. It gets broken apart into our ions, but there's still the particles that came from the salt. Okay, so this solution, there's some terminology about solutions that I want to remind you of. And one of them is solvent, and one of them is solute. So we have seen these words before. Water is the solvent because it is what does the dissolving. And our salt is the solute, and this is because it is a substance that is being dissolved. Okay, so solvent and solute are important terminology for us for when we talk about concentration, because concentration is the ratio of solute to solvent in a solution. So it's telling us how much solute, or salt in this case, is dissolved in a certain amount of solvent or water. Okay, and so there's lots of situations where concentration is really, really important. And one of them that's really that sticks out in my mind is when my husband is figuring out how much chemical fertilizer to put in a big, huge tank on a sprayer to go and apply fertilizer to his crops. So he adds a little bit of the really concentrated fertilizers into this tank, and then he fills it up with water. Now, he has done an awful lot of calculations to figure out how much of the fertilizer to put in the water tank to get a specific concentration of fertilizer to spread on his field. And because he wants a specific concentration of fertilizer spread on his field, and there's a whole bunch of math that happens to figure out that concentration. But that's an example where concentration is used in real life. Another example is when a hairdresser figures out the concentrations of solutions to use when they are dyeing your hair. Okay, so when we think about concentration, just a little reminder that there's two, that when you have solutions that do not have a lot of solute particle, it's called a dilute solution. So there's a small amount of solute in the solution. So that's kind of right over here. There's just a handful, 3 solute particles in this maybe beaker that I have some of water. And now if you have a lot or a large quantity of solute particles in the solution, you have a more concentrated solution. So an example of this would be like, if you go to make yourself some hot chocolate at home and you have the hot chocolate powder and you've boiled some water in your kettle and you put 1 scoop of hot chocolate powder or just a little bit of hot chocolate powder into the water and you stir it up and you take a drink and it tastes like hot water. Okay. That is a dilute solution. There's not a lot of hot chocolate powder dissolved in that mug of hot water. Now, if you add 2 or 3 or 4 scoops of that hot chocolate powder and you stir it up and you take a sip and it's really chocolatey and rich, you have something called a concentrated solution. There is a large amount of hot chocolate powder dissolved in that water. Now, when we are dealing with concentrations, when my husband is figuring out a concentration of fertilizer, he's often expressing concentration in a percent. So it's really common for concentration to be expressed as a percent in the real world. So what they do is there's a mathematical formula for concentration, and it's right here. This is our general formula. It's the quantity of solute divided by the quantity of solution. Now, when we think about substances that can be concentrated, there's several different ways to make a solution. And I've talked about 2 different ways already in this lesson. So if we wanted to make a solution of fertilizer for the fertilizer tank on the sprayer, I would be using a volume by volume concentration. And that's because I am diluting a liquid solute but into a liquid solvent. Another way of volume by volume is if you make like juice by concentrate. So sometimes you buy those cans of frozen juice, and I like to leave it under the counter to defrost a little bit, and then I have a liquid, a can of liquid concentrate. I put that in the pitcher, and then I add a whole bunch of water. I'm mixing a liquid solute with a liquid solvent. So if I wanted to figure out, communicate the concentration of that by saying it's a volume by volume concentration. Another example is that if you look at a bottle of vinegar that you have in your pantry, you're going to see somewhere that it probably says 5% volume by volume. So what that's telling you is that in that giant jug of vinegar, 5% of it is pure acetic acid, and the other 95% of that bottle is just plain water. Okay. So it's telling you the concentration of the vinegar is 5% volume by volume acetic acid, because vinegar is just diluted acetic acid. Now, sometimes solutions are not prepared volume by volume. They're prepared with a solid solute. So this is a weight by volume concentration. It's when you have a solid solute and a liquid solvent, and the solution is made that way. So this would be, if I was to communicate the concentration of my hot chocolate, I would use a weight by volume concentration, because I've used a solid hot chocolate powder and I've dissolved it in a liquid water. Now, a common example is hydrogen peroxide, which lots of us probably have in our cupboard somewhere. It is prepared by weight by volume, because hydrogen peroxide can be found as a solid. So it is a 3% weight by volume. So that means that in your bottle of hydrogen peroxide, 3% of the contents of that bottle came from a solid hydrogen peroxide substance, and the other 97% of it came from or is liquid water. And then finally, the third way to communicate our concentration is a weight by weight. And this is when you have a solid solute and a solid solvent. And this would often be used for creating steel. I also think it's used in white gold because white gold is a solid. It is an alloy. Okay. The two most common that you will probably come across in your everyday life is your volume by volume and your weight by volume. So the reason we're looking at this is because it's important to be able to calculate our concentration. So we're going to look at how to calculate percent or we're going to look at how to calculate our concentrations and communicate it as a percent. So I just want to remind you, just recalling that general formula for concentration, it's mass of solute, it's the amount of solute divided by amount of solvent. Now, we want to turn that into percent, so we're going to multiply by 100%. Okay. All right, so our concentration, actually, I'm going to backtrack. Our concentration of our solution is going to equal our mass of solute divided by the volume of the solution. Now, sorry, I said solute and I meant solution. And then we multiply it by 100% to turn it into a percent. Now, this is just exactly the way that you would probably think about calculating your mark. What you got divided by total amount times 100. So here's our first example. All right, here's our example. We have a 600 milliliter solution, contains 160 mils of pure acetic acid. Calculate the volume by volume concentration of the solution. So this is pretty straightforward because it gives us all the information we need. We have a formula. We just have to plunk in our numbers and punch it into our calculator. So we have a 600 mil solution. So that's telling us that our volume of our solution is 600. And it also says that it contains 160 mils of pure acetic acid. So the volume of our solute is 160 mils. We know our formula is concentration of solution is volume of solute divided by volume of solution times 100%. So we just plunk in our numbers. Our solute was 160 mils. So we put that here. Our volume of our solution is 600 mils. And then we times it by 100%. 10 minutes. Now, I just want to point out to you, and I want you to notice that I wrote the formula first. So I wrote right here the formula for concentration. And this is proper scientific format for good communication marks. So you're going to write your formula first and then plunk in your numbers just like I showed you, and then put it in your calculator. And when you put it in your calculator, you can put it in your calculator all at one time, but I'm going to suggest to you that you do this first in a bracket. So put in your calculator, bracket 160 divided by 600, bracket times 100. Then it's going to spit out a big number. You can write that down, but you have to make sure your answer has the correct number of significant digits. Just like we learned when we talked about our significant digits. Both of our pieces of information over here have 3 significant digits. So that means that our final answer can only have 3 significant digits. So you have to round that big number that or large number of decimal points your calculator gives you to 3 significant digits. And then for proper communication, you're also going to make sure that you write your unit after your answer here, percent. I also want you to note that I included my units in beside my numbers. So 160 mils and 600 mils is there. Again, that's proper communication. So you always want to include your units beside your numbers. So we have our answer, 26.7%. And then usually in science, we write a nice therefore statement. The volume by volume, therefore, and that's what those 3 dots means. The volume by volume concentration of acetic acid solution is 26.7%. Now, sometimes you will have concentration and it wants you to rearrange your formula to solve for something else. And that's what's going to happen in example number 2. So in example number 2, it says how much solute in grams must be added to create 450 mils of a solution with a concentration of 3.7%. So what you have to do, again, is probably in your best interest to write out your givens. I always like to write out my given information because it helps me keep track of what I have. We have a 450 ml solution. So that's our volume. And we have a concentration of 3.7. So here's our concentration. Sorry, my children are being rowdy in the next room. So our formula, concentration equals mass of solute divided by volume of solution times 100%, has to be rearranged for mass. And I've already done the work for you here. So what you have to do is you have to take your volume, multiply it by concentration, and then divide it by 100%. And that will give you your mass. And then you're just going to plug in your numbers. I want you to notice again, I included my units after my numbers because that's for good communication. Punch it into my calculator, gives me a nice answer, 16.655. And I actually did not follow my own rules here because my significant digits tells me that my answer should only be have 2 significant digits. So our 16.65 should get rounded up to 17 grams. Again, I've got my units, my proper significant digits. I'm only using 2 digits because this number here, 3.7, has 2 significant digits. And I've got a nice therefore statement to finish off because I have a word problem. I probably want a nice therefore statement. Therefore, the mass required to make this 3.7% solution, that should say 17. Okay. All right. So I'm going to give you some practice for this. You're going to get really awesome at calculating concentrations. Most household substances communicate concentration as a percent, but in the chemical world, in chemistry, in industry, and often sometimes in the medical field, concentrations are communicated a little bit differently. And that's in molar concentration. And we're going to talk about that next.